Hey everyone, welcome back to my channel. Today, we're going to discuss something that's all around us in everyday life: solutions, colloids, and suspensions. These might sound like boring textbook terms, but stick with me. I'll show you how these concepts shape everything from your morning coffee to cutting-edge industrial processes. Let's get started. First, let's talk about mixtures. A mixture is when two or more substances come together without chemically combining. Think of it as a party. Some guests mingle, some don't, but no one gets married. Now, depending on how well the guests mix, we get three types of mixtures: solutions, colloids, and suspensions. Let's start with solutions. A solution is a homogeneous mixture, which means it's perfectly uniform. The solute, like sugar, completely dissolves in the solvent, like water. You get a homogeneous mixture, so smooth that it's impossible to see or separate the particles. The particle size here is super tiny, less than 1 nanometer. Now comes some other examples: saltwater, vinegar, or sugar dissolved in tea. Solutions are also vital in the pharmaceutical industry, like saline solutions used in hospitals. Some key properties of the solution are here. They're transparent, means clear as crystal. You can't separate them with filters because the particles are just too small. And here's a cool one: solutions don't scatter light. So, no matter how much you shine a flashlight through, it passes right through without being blocked. That's why solutions are like the VIPs of the chemistry world: simple, elegant, and efficient. Next up, colloids. These are heterogeneous mixtures, but don't let that scare you. Colloids are mixtures where the particles are larger than in solutions but still too small to settle. The size of the particles is between 1 and 100 nanometers. Now comes the examples: milk, fog, or even paint are colloids. Colloids are behind the magic of whipped cream, cosmetics, and even clouds. Some key properties of colloids are here. They're not transparent, but they still appear uniform to the naked eye. You can't filter out the particles, but techniques like centrifugation can separate them. And here's the fun part: colloids show the Tyndall effect. Look at that. The light scatters because the particles in a colloid are big enough to interact with the beam. This effect is why headlights in fog look so dramatic. Finally, we have suspensions, the most obvious and dramatic type of mixture. These are heterogeneous mixtures where the particles are huge, bigger than 100 nanometers. They settle over time, which is why your muddy water separates if you let it sit. Now comes some other examples: sand in water, orange juice with pulp, and many more. Suspensions are used in construction, like cement mixes, and in agriculture, like spraying pesticides. Some key properties of suspensions are cloudy and non-uniform. You can easily filter the particles out. They may scatter light, but it's not as consistent as colloids. Suspensions are like chemistry's drama queens. They're bold, obvious, and don't like to stay mixed. Now, let's summarize everything with a simple table to make it super clear. A solution is homogeneous, while a colloid and a suspension are heterogeneous. The particle size in a solution is less than 1 nanometer. In a colloid it is between 1 to 100 nanometers, and in a suspension it is greater than 100 nanometers. A solution appears transparent, a colloid is cloudy but uniform, and a suspension is cloudy and non-uniform. The particles in a solution and colloid do not settle, but the particles in a suspension settle over time. Separation of particles in a solution is not possible, while centrifugation works for a colloid and filtration works for a suspension. The Tyndall effect is absent in a solution, present in a colloid, and maybe present in a suspension. Don't forget to like, subscribe, and hit the bell icon for more fascinating chemistry content.